So today's agenda, the agenda for today, we have two more sections within Chapter 9 to cover. One of them is on calculating something called effective interest rate. The other is on equivalent interest rates. And there's another bullet point in red for Chapter 9, which is to tie up loose ends. And what I mean by that is if you've tried the quiz online, if you've tried any of the quizzes online, you may have encountered a question which you may not have known how to proceed in terms of solving it. So we'll talk about that right after these two sections are covered well. After that, we have three sections to talk about from Chapter 10. The third one I don't think we'll get to today. So as long as we get to about here, as long as we at least start 10.2, we are good. I think next week we can just set aside for a lot of different calculations for different scenarios. And next week we can cover both of these in more detail. Everyone okay with what we're about to do? Everyone has the calculator? What happened? Let's start with two announcements though. I forgot to actually post an announcement on Blackboard, but if you check the critical path now for the course, you will see the quiz deadlines on the critical path also. So just so everybody here is aware, the first two quizzes they're now due on the 3rd of February. So that's 2 weeks from now. It's a Sunday, I believe. So you have lots of time if you haven't already done so. Okay, so if you haven't already done at least quiz 1, you have 2 weeks to do both quizzes. I would recommend doing them both before our first test, which is also 2 weeks from now. Exactly 2 weeks from now in this room. Okay? And the third announcement, you can decide if this is good news or bad news or just news. It looks like I'll be here with you for till the end of the semester. Okay, so I began as a sub in this for this particular course, but it looks like I'll be with you until the end. So with that said, let's start with section 9.7. Now, how many of you already know what effective interest rate might mean? Does anyone have any prior knowledge of that term? Okay, that's fine. Let's do a quick check. I'm just going to make up an example, and I just want to make sure everybody is on board, okay? So if I say something like, or if I give you a fragment of a question, so let's say just if a fragment of a question. What can you tell me about, what can you identify from here? So what's this guy over here? What kind of interest rate? Is it, anyone remember? Nominal interest rate. And the second part tells you how frequently it's being compounded, right? So that tells you, it can tell you two things, the compounding period, or you can also get from their compounding frequency. Okay, now nominal interest rate, as I hope everyone remembers, we call it IY on the calculator. Compounding frequency is CY. All right, now what else can you tell me about the nominal interest rate? I just want to check something here. It'll be useful for the very next part of the discussion. Hey.
That's the interest rate for the entire year.
Exactly right. It's an annual rate, and then with nominal interest rates, you have an annual rate, and then you also have information about how frequently compounding takes place, right? But the key thing to remember is it is an annual rate, because if you had to find the quarterly rate, what would you do? Divide by 4, and that would be called not nominal rate. It would be called the periodic rate, right? So this is still an annual rate. Quarterly rate would be that divided by 4. So 2%. Everyone clear on that? And periodic rate would be something like 2% per quarter. That's how you would state it. Can we keep going? All right, now the idea of effective interest rates. So I'm going to sort of give you a really short and sweet definition here at some point, but let's first look at an example as to why or where this is useful, this idea. Let's say, I'm hoping everyone here has a savings account of some kind. Let's say you were shopping around for a savings account, just a regular savings account, something that gives you compound interest guaranteed. So not stocks and not bonds and stuff. If you had an option between these two savings accounts, based on this information, which one would you pick, blue or red? How many of you would choose blue? Just a quick show of hands. Okay, 1, 2. Okay, how many of you would choose red? A few more hands, and everybody else is undecided? Okay, no, that's fine, that's fair. So all of you who picked, the two of you who picked blue, what did you base your decision on? Compound daily. Okay, so you're looking at the frequency of compounding. Everyone who picked red, what did you base your decision on? The number here? The fact that this number is bigger than that number? Is that it? Is that the main reason why you picked it, or just? Okay. Oh. Well, actually, so based on just the frequency of compounding, if you forget the numbers here, which frequency is better? Daily, because? Right. The interest that's being earned is being added back to the principal more frequently, so your new principal then gains more interest. So there should be more growth here, if you only look at the frequency. Right? But based on the numbers, which one should achieve higher growth? If you only look at the numbers? The right one, 9.15. It's slightly more than 9%. Okay, so if you were to decide between which account is better for you in terms of investment or savings, it's not an easy choice. If you only had to look at the numbers and decide, you would choose this. If you only had to look at the frequency and decide, you would choose blue. So something that helps us decide is the idea of an effective interest rate. Okay, so let me give you the definition now. It's an annually compounded interest rate. And the thing about the effective interest rate is this blue rate currently is compounded daily. Its effective interest rate would be compounded annually, but it would still achieve the same future value. Did you catch that last part? It would be the effective interest rate for this account would be the same, would be an interest rate. It'll have a different number, but it's compounded annually, but it still achieves the same future value. So the same amount of interest is generated when compared to this rate, compounded daily. And the effective interest rate for the red account would be another rate compounded annually, which also achieves the same future value as this. So if you find the effective rate here and if you find the effective rate here, it becomes easier to compare which product is better, because both of their frequencies are now the same. Their compounding frequencies would be the same. And I can really quickly calculate. I'll show you how to do the calculation very soon, but for now, let me just show you something really, really quickly. If you use the calculator, the effective rate here comes out as 9.41%. Well, 42%, I should say, if I round it. And keep in mind that effective rates, by definition, are annually compounded, which means this is compounded annually. You don't have to write this part. It's part of the definition of effective rates. And if you were to do the same sort of calculation for the second rate, you would get an effective rate of 9.36%. And again, this part you don't actually have to mention. It's supposed to be understood based on the word effective interest rate. So based on this now, which account would be better for you? The blue, for sure. Because now that we've made the frequency the same, only thing you have to look at is the number. The higher the number, the more interest you get. Does that make sense? Just the idea? Okay, so I didn't show you how to calculate effective interest rate. If there is a way to derive the actual formula for it also, if you're interested in that. But remember, in our course, this is our go-to method for calculations. So let me, in the very next step, show you how to do this. You guys ready? Yes? Okay, so to calculate effective interest rates, on our calculator, there is a special mode we have to go into. So for any special mode, remember, you have to press second. And right above the number 2, what do you notice? ICONV, right? That just stands for interest conversion or interest rate conversion. So if you press second and ICONV, or so second and 2, I mean, the first thing you should see is NOM. And I hope everyone realizes what this is. Nominal interest rate, right? I wish they just used IY, but anyway. Nominal interest rate. So in the previous example, for instance, for the blue question, you could put in 9 as your nominal rate, and you have to press enter. So 9, and then press enter, and then the calculator has accepted your input. So instead of scrolling down now, scroll up. So if you press the scroll up button, you should see CY. Set it to, I think blue had daily as the frequency, so 365, and then press enter. And scroll up again, and you'll see EFF, which is the effective interest rate for those two inputs, based on those two inputs. And just compute. So if you press CPT here, you should get 9.416 something percent. So this gives you 9 point, let's say 42 if I round it. So at least on the calculator, the procedure becomes extremely simple, as long as you put in the right inputs. If you were to use formulas, it takes a little bit more time, a little bit. Let me just really quickly check something. What is the compounding frequency of this number, this rate? Annual. Remember, effective interest rates have annual compounding frequency. Everyone okay with the method so far? Okay. In that case, let's see. I just want to mention one additional thing. If this shows up on a test, for instance, the minimum you have to show me on paper is this part here. What inputs you are putting in. I mean, you can avoid the arrow buttons, but just nom equals some number, cy equals that number, and effective you're computing, and so on. Just show me the inputs. Show me what you put into the calculator. Can we try some examples? Ready? Okay. Anyone still writing this down? You are? Sure. Let's try examples. There are 4 questions in total. And questions 3 and 4 introduce a slight variation, let's say. Question number 4 especially tests your understanding of the idea of effective rates. We'll get to that soon. Let's do 1 and 2 and 3 first. Just let me know what if you're able to get the answers for 1 and 2. That means you're ready for number 3 after that, and I will reveal the answers very, very soon. How many of you got question 1 right? Okay, that's good. Question 2. And how many of you got question 3 right? Okay, so in question 3, I want to point something out. Notice the way these rates are given to you in questions 1 and 2. When you see this, I want you to be absolutely certain that that is the nominal rate given to us. 4% compounded semi-annually, 8% compounded quarterly. Just like I showed you at the beginning, if you see something like this, that has to be the nominal interest rate, right? But let's take a look at this question here, number 3. Is that in that same format? Does it say 1.2% compounded monthly? No. So what rate is that? That's not the nominal rate. That's what I want you to notice. It's periodic. This is the periodic interest rate. And how would you find the nominal rate from here? Yes. So because it's a rate per month, the nominal rate, which is an annual rate, would be that number times 12. Exactly. So it needs to be 1.2 multiplied by 12, which is 14.4. So when you can do this math in that special mode. When you get 14.4, press enter. And CY is going to be 12, and then you can compute effective. And if you're okay with that, try question 4. Think about it. I'll take it up very soon. How many of you are still working on question 4? Okay. Do you notice how question 4 is completely different from 3, 2, and 1 based on the kind of information they give us? They didn't give us nominal interest rate. They did not give us compounding frequency. Instead, they gave us this number, which is the present value. Yep. And then they gave us this number, which is a future value, and then they gave us time or duration of investment. So in order to solve for the answer in this question, we cannot use this worksheet and this special mode anymore because we don't have those inputs. Instead, we're going to have to use something we've been using for the past 2 weeks. That table, the TVM worksheet on the calculator. And even if you decide to use this, you can only get to the answer if you, once again, understand something about the effective interest rate. Okay. So let's begin with the numbers we do know. $8,000, you said it's PV. I hope everyone agrees it needs to be negative. In this case, well, let's assume it's an investment, so negative 8,000. Future value would be 13,663.19. This number here I'll record as time, 6 years, and it needs to be used to calculate N. What should payment be? 0. As long as you're able to figure out these two numbers, you'll be fine. Okay, why 1? Annual compounding, because it's in the name itself. When you say effective interest rate, it means annual compounding. So this has to be 1, this has to be 1. And we're going to compute IY at some point. So N is now CY times T, which is 1 times 6, which is 6. Yeah. And with these values, if you compute IY, you should get 9.33 to 2 decimal places. Is it like a 0 or something after? 9.330. 1. Okay. .33. That would be the answer here. So we talked about effective interest rate. Now we'll talk about equivalent interest rates. Equivalent, the word equivalent on its own just means equal in value. When applied to interest rates, we're talking about 2 or more nominal interest rates. And they can have different compounding frequencies, but they still produce the same amount of interest in total, which means they also produce the same amount of future value. Okay? So you could say this is an extension of the idea that we just talked about. And I think running through some examples will help to reinforce this. Again, equivalent rates are two or more nominal interest rates with different compounding frequencies that still produce the same future value for the same present value. So if you put in the same amount of investment in two accounts, and if they produce the same amount of FV after a certain amount of time, the rates for those two accounts are equivalent. Should we try some examples? Okay. Let's go into the second part of this one here. There are 3 questions in total. Let me do at least the first one with you. And you can try 2 and 3. And notice what the question says. It says 6% compounded monthly is equivalent to what rate compounded quarterly? Which is another way of saying 6% compounded monthly produces the same future value as what rate compounded quarterly. And a good way of approaching this, this is what you can do in the beginning especially, is to create 2 boxes. You'll see where I'm going with this very soon. And in the 2 boxes, you would put in the 2 nominal interest rates that you know in the situation. So, for instance, this is one nominal rate, that's another. And it doesn't matter which box you choose for the first rate. I'm just going to go with the left one for now. But in the left box, make a note of the value of the nominal rate and its compounding frequency. In the other box, make a note of what you know about the second rate. So this is before we even take out the calculator, just to understand what we're dealing with. Would you all agree that in the first box, I can put 6 and what number? 12? Okay, so I'll put 6 here, 12 here. Everyone's okay with that, right? In the second box, we only know CY, which is 4. And nominal is missing. So as long as you set it up this way, on the calculator, what we end up doing, if someone has already figured it out, we can find the effective rate for the nominal rate that we know everything about. So I'd say compute the effective rate here. And then once you have this effective rate, find the nominal rate over here based on a slightly different CY. I'm going to show this to you on the calculator very soon. But I think some of you may know what I'm talking about here. But that's the general idea. Start with the box which contains the nominal rate where you know its value and frequency of compounding. Find its effective rate and then go towards the one that you don't have complete information about. Actually, maybe I could just show you right here. So if you go into the second, if you press second and 2 once again, because it says I conversion. Let's start with the nominal rate. You would enter 6 here, scroll up, enter CY as 12, scroll up. When you get to effective, you should when you get to effective, you would compute. And what number do you get? Oh, 6.16, okay. 7, 8 something, okay, ... If, again, on the test or something, show me that you did find this number. But don't round it, don't do anything, don't even clear your calculator. As soon as you have this computed, scroll, I guess, down. I think down would be better. If you scroll down, you should come back to CY. So scroll down from here when you get to CY, change that to 4. And then compute nom, and you would get 0.03%. And you just had to mention its compounding frequency manually. So 6.03, it's rounded, right? There are more digits? 0.005. Okay, I'll just round it to 2 places for now. 6.03 is the answer. So you could state the final answer as 6.03% compounded quarterly. So if you're okay with that, try number 2, and then there's question number 3. So number 3 especially, let's see. Here are my 2 boxes. You don't have to make the boxes, but here's my 1 rate, here's my 2nd rate. So let's say the blue rate represents the nominal rate for which I know everything. So there's a 5% rate compounded monthly, so 5 and 12. And for the rate that's unknown, what do we know about it? It's still compounded monthly, right? It says calculate the new rate compounded monthly. So this is the blue rate. The red rate we're looking for is here. So, sorry, small mistake with the symbols here. CY and IY. I wish I could say I was testing you, but no, that was an honest mistake. It's still 12. All right. So remember to always start with the box or the rate for which you know everything about. Find its effective rate. And when you compute the effective rate, what did it come out as? Right, 5.0, sorry. 11 something? Sorry, okay, thank you. Dot, and so on and so forth. Now, the only thing that's different in this question is we cannot use this rate yet to find the new nominal rate. Because of something in the question, it says the bank, right, decided to deduct 2% from the effective rate. So as soon as you find this effective rate, you can minus 2 directly. You could subtract 2 from here, press equals, and whatever you get 3.116. You have to press enter at this point. You have to. If you don't press enter, your calculator will not accept it. So press enter at this point, and then you can go into this box. The only thing you'd have to go to is CY didn't change, so go to N. Why am I calling it N? Nominal. And calculate nominal at this point. And you should get 3.07 something. So this is me tying up loose ends. Okay, so chapter 9. It's not the best title. Do you remember this question, some of you? We did this in week probably 1, if not 2. Probably week 1, yeah. And I hope at this point, this is a good time to check, everyone can answer this question. We don't have to do it again, but can everyone answer this question? And we'll be using the TVM worksheet here, which has the N which has those main inputs. So It's good to see that everyone here can do that, at the very least. But what if the question had something like this? I took the same question, but I erased a few bits of information and I made it into that. Okay, so it's no longer being invested for, 3 years? It's now being invested from a specific start date and until a specific end date. So the question still remains the same. What was the accumulated value of the investment? And again, if you've tried the first quiz, you may have come across a question like this. And maybe you figured it out. Maybe not.
An extra step to figure out at what point you're starting and how long
Yes. Yeah.
years that is.
Mm-hmm. So you're right. So let me just build on that. Let me just first begin with the fact that we still need this table. Let's try to fill out this table first. IY is going to be 4.8. Compounded annually means these two are the same in this case. PV is, okay, PMT is 0. FV we have to compute. The problem seems to be N. And before you can use the TVM worksheet on the calculator, you have to calculate N. So we know N is CY times T. We know CY is 1. We just don't know T yet. So I'll just keep that blank for now, and I'll try to find T. So the thing about the duration of the investment, we have two dates. 25 Jan 2015 to 27 April 2018. I'll zoom back in on the blue table quickly, but soon. But let me just look at this first. Now, as long as you're able to find the gap between these two dates, you're on the way to the answer. You'll be able to find the correct T value. But it has to be precise. It has to be a precise number. So you cannot say approximately 3 years or something, 3 point something years. You can't say that. And we'll be using the calculator to help us out. There is another special mode on the calculator to help deal with dates. So the way you access it is by pressing the second button. And I believe above the number 1, you should see date. By the way, on Blackboard, if you check out the calculator FAQs folder, there's a video titled How to Calculate N when 2 dates are given. That's the same idea. Anyway, coming back to this, since we have it here, let's talk about it here. When you press second and 1, what's the first thing you see? Okay, if you've never used the date function before, it has a really old date, I think, currently entered. But you should see DT1, which is date 1, your first date. And our first date needs to be this one here. Right? Okay, there's a really weird way you have to enter the dates. So you'll get used to it. Here's the format. The date needs to be entered in month, decimal point. That decimal point is extremely important. 2 digits for the date and 2 digits for the year. But, sorry, say that again?
No, sorry, there's no decimal.
No, yeah, this is what I meant by weird. If you don't put that decimal point, you won't be able to enter it properly. So, month, date, decimal point, 2 digits for the date, 2 for the year. Also, for a month like January, I know it's 01, but you won't see the 0 show up on the calculator, and that's fine. Don't panic. If it's October, you'll see 110 and so on. Okay, but you still have to, just as practice, punch in the 0, just to be sure. No dots, no, and only the last 2 digits of the year. Okay, so date 1, it's 25 Jan 2015. How would you write it in this format? Okay, And just as a reminder to everyone here, just to practice putting in two digits, I'm going to put in 0, 1. I know the 0 won't show. Decimal point, 2, 5, and then 1, 5. As soon as you have that, press enter. You have to press enter. And when you press enter, it should show you it should show you the correct date. You can review it. You can see if it's right or not, if it's right or wrong. If you're happy with the date, scroll down. And you see DT2, which is date 2. Enter the second one in the same format. So, month number. Say that again? I'm going to forward your question to the programmers of the calculator. Month first. 04 dot 27 and then 18. And remember to press enter, otherwise all that effort is wasted. Once you're happy with the date that it shows, scroll down and you should see DBD, which stands for days between dates. And because that's what we're trying to find, guess which button we must press? CPT. Great. And what number does it give you? 1188, which makes sense. It's definitely more than a year. So more than 2, in fact. Actually, more than 3. So that's the number of days. So at this point, what you should do is, I think, if you, just to get out of the date worksheet, you can do 2 things. You can store this, or if you press CE, I think it disappears. The date stuff disappears. The DBD stuff disappears. And you should still have this number on the screen. Yeah. So divide this guy by 365. What number do you get? 3.2. Okay, I'll just say something like that. This is now in years, and you need to multiply that with the CY value to get your N value, which is 3.24 ... periods. Again, I'll zoom in on the other table very soon, but is everyone getting this? Something like that? Yes? The days between dates that you get, you have to change it into years. Once you have it in years, you can multiply with your CY value to get that for N, and then press N to assign it to N. Once you've done all that, you are ready for all of this and to compute FE. So, to those of you who said there's an extra step, you're right. More like an extra set of steps, but every time you see 2 dates given to you in these situations, you'd have to do this. Also remember not to round this number, right? Keep it unrounded, multiply it directly with CY to get that, keep that unrounded, and assign it to N. I may have made a mistake. I was just counting on your on everyone's input, but 3.2 something, right? Yeah. Okay, so let me just do that instead here. But key thing is you're not rounding it. You're not rounding at all. 3.2 ... So if you do the quiz, you'll see a question like this. And this is what you'd have to do. Questions?